Hello, everyone. This is Cameron Smith from TechLogix here today to go through another one of our 20-minute webinars. This one is on fiber optic installations and more specifically, common applications and issues that we see in real-world installations. You know, this is a topic that gets a lot of attention right now. Folks are starting to warm up to the fact that, look, we need fiber optics. We need fiber optic cable. We need to think about faster speeds and higher bandwidths and future-proofing. But where do I start? What type of applications use fiber? How can I start to think about incorporating an optical cable into my installation? And today, over the next 15 to 20 minutes, we'll look at some of those common applications and we'll talk about what type of pitfalls we see when we start to pull the cable and connect the electronics and, you know, really move forward with the next evolution within cabling in the AV industry and also datacom security, some of these other vertical markets that a lot of the AV integrators work in. Now, before we get started, a couple things I want to mention. We're going to roll through a lot of content in the next 20 minutes. We're going to move through it fairly quickly to help you get in and out and on with your day. So I would appreciate it if anyone has any questions, you can type those into the GoToWebinar software. We'll get to those questions at the end of the session, or we will give you a phone call or an email and follow up with you and get you the right answers. Also, this is being recorded. You will get a link to the recording after the session. You will also see some links to these applications we are looking at today. These are online. You can sort through these. You can look at the different products. They're in a nice centralized repository on the TechLogix website. So without further ado, let's start talking about some applications, and let's start the conversation with Demarc wiring. Because frankly, this is one of the top places we are seeing fiber optics being installed, whether we're talking about residential and we're wiring the Demarc of a house or an MDU or a commercial building. When people think about fiber optics, they tend to think about that feed, that service feed coming into the building. And this is also an area where we tend to see some issues, okay? Folks tend to pull the wrong type of fiber to the Demarc. Now, we're not going to get into all the different types of connectors and cables in this short little webinar today, but the good news is we have that information on our website. We have a lot of other training modules. You could spend 20 minutes just talking about connectors, and good news, we got a video that goes over that. You can watch it at your convenience online from the training page on the TechLogix website. But know this, you always have to pull single mode fiber to the Demarc, okay? And frankly, anything before the modem needs to be single mode fiber optic cable. Why? Well, because there's two different types of fiber, single mode and multi-mode. Single mode has a smaller core size, and a smaller core size means you can go long distances. And when we talk about service feeds, when we talk about Demarcs, we're talking about long distance optical cable distribution. And anything before the modem, I can't say this enough, anything before that modem really needs to be single mode fiber optic cable and corresponding single mode connectors. Usually we see an SC style connector in the Demarc, whether it's an outdoor wall box. The couplers are they're single mode. They tend to be SC style. And here's the nice thing. We definitely color code things within the fiber optic industry. So as you talk to the service provider, provided they've been identified prior to you pulling cable, it's always a good idea to ask, what type of connectors do you recommend? What do you want to see in this Demarc box? Is it angled? Is it flat? Is it polished? If it's a green connector, it's going to be an APC or an angled connector. These are very commonly used in telecom wiring, Demarc wiring. If it's blue, that's a standard connection, okay? That's what we typically see in networking, like inside plants. So inside the network room, inside the network switch, we typically see blue connectors. So pull single mode, think about SC connectors, think about SC style couplers. Definitely you should be in control of where that outdoor Demarc box goes. We always recommend that because you know where that feed is going into the building, or really where it should be. So this is something that we see very commonly deployed in fiber optic installations. Now, once you get inside the building, now we're talking about connecting networks. Another very common application for fiber, taking two network switches, connecting them together. And why do we see this? Well, fiber handles a lot of bandwidth. If you're pulling cable, pull fiber, you are future-proof. But we also get the distance out of fiber. You know, that's another major benefit that we see here. You are not limited to 100 meters or 330 feet. You can literally connect network switches over miles of distance. Now, you are seeing more fiber-based network switches. These have SFP ports on them. These come in 1 gig varieties, 10 gig varieties, even 40 and 100 gig varieties. Though what we see most commonly deployed out there, especially when we're talking about consumer technology, you know, a lot of commercial applications, these are 1 gig and 10 gig switches. And if you have a switch that is fiber ready, that is where you're going to use an SFP transceiver module. These tend to be standardized across all the different makes and models of switches. You pop these into that SFP port. Now you are fiber ready. Now, a couple of things I want to mention, just like we were talking about with the Demarc, there are two different types of fiber, single mode and multi-mode. These SFP modules are going to be specific to one type of fiber or the other. Know what kind of cable you're using, use the proper module, pop it in those switches. You are now fiber enabled, and you can literally connect two switches up to several miles, 6 miles, 12 miles. You can go long distance. We're dealing with lasers and optical glass. Okay. Now, one other product that I want to mention here, because a lot of people don't know it exists, direct attach cables. These are cool. These are for short distance connections. So if you were just stacking a couple of switches in the rack, we use these direct attach cables. It's basically a pre-made cable that has the SFP modules already on there. You don't need a secondary fiber optic patch cord to connect these two things together. Now, we can put this all together, everything we've talked about so far, and this is where we're wiring two different networks in two different buildings, okay? Best practice says if I'm connecting two buildings and the networks within those buildings, I want to think about some sort of patch point, like an outdoor enclosure, maybe an indoor demarcation enclosure. But we want to transition from that outdoor cable to that indoor cable. Why? Because when we're dealing with this outdoor cabling, it may be direct burial, which is armored. It's really thick. It's kind of hard to pull. It's heavy, right? But it survives a shovel. It survives being buried directly in soil. Well, we want to transition to that indoor riser or plenum rated fiber optic cable where armoring isn't necessary. Or maybe we're pulling conduit, right? Conduit between two buildings. Well, in that application, we don't need armoring, but we do need an outdoor waterproof cable, okay? Another very common part of the installation. Well, we want to transition from that conduit to the indoor rated cable, whether it's riser or plenum. So think about those same wall boxes, outdoor rated wall boxes that we use for the Demarc. Well, we can use that to transition networks between two separate buildings. And remember, fiber lets you distribute these signals over thousands of feet. Very powerful that way. Zero frame rate latency. It is a powerful solution for long distance connectivity. Within the buildings, very similar to the building-to-building connections, but specifically within the buildings, we see a lot of MDF to IDF wiring. All right, what does that mean? Main distribution frame are kind of our central connection point to intermediary distribution frames. Think of these as the distributed distribution points. Maybe it's in each floor of the building. Maybe it's in each wing of the building. Maybe it's a residential MDU, multi-dwelling unit, right? Where we've got each apartment, each condo gets its own feed. Well, we see this MDF to IDF wiring all the time, okay? And in this application, it's very common for us to integrate enclosures. Now, yes, technically, outdoor wall box, that's an enclosure. It's a type of enclosure. Do we see that in MDF and IDF? Sure, plays a role. However, we tend to see more rack tray enclosures and metal wall box enclosures, okay? And the reason is when you're wiring an MDF to an IDF, odds are you're going to use multi-strand cable. And frankly, you get into some pretty high strand counts, meaning 6-strand, 8-strand, 12-strand, 24-strand, and even beyond that. Why? Because we're not always just moving networks. Sometimes we're incorporating digital signage, video. You know, we're getting into all of these different signal formats and signal types, and we want to branch those out throughout the facility. Well, we need to manage that multi-strand cable. We need to protect the strands. We need to incorporate service loops. We need to create patch points. And this is where the enclosure really plays an important role. So same fiber optic cable, whether it's multi-mode or single mode, same connectors, LC and SC style. And again, there's a lot of training around this on the TechLogix website. You can watch videos, quick little read articles, things like that. But think about these enclosures. It will be part of how you're wiring that MDF to IDF. And call us. We've got engineers on staff where we can walk through these applications, you know, help you uncover how this all comes together as a system. Now, here's the reality, right? We're talking about fiber, lasers, pretty cool, pretty exciting. But the reality is, do we see optical ports on most of our electronics? Not really. Yes, more and more network switches are fiber enabled. Yes, more and more we're actually using our fiber to distribute audio, video, network, security, access control, whatever it may be. However, the vast majority of devices, and it will be this way for some time yet, are RJ45 based. And this is where one of your best friends will be the media converter. So it's kind of like a little network switch, okay? A little network switch that just has 2 ports on it. One port for RJ45, your twisted pair device, and one port for fiber. We're taking an electrical signal, like your twisted pair, and converting it to an optical signal, like your fiber optics, okay? Media converters are not that expensive, you know, under $100 trade price, and this will allow you to incorporate all of these legacy devices, all of these copper-based devices into that fiber optic infrastructure that, oh, by the way, fiber's future-proofing the install. So today, we may have a copper-based device. Tomorrow, we may want to upgrade to fiber. We may increase our speed, our bandwidth. Great, pull the cable once, you are ready. The nice thing about these media converters is that they are very flexible, okay? They do allow you to integrate all of these other electronics that may be already part of an existing system to this new cable run that you are expanding onto the system, okay? We're gonna add a new floor. We're gonna add a new building. We're gonna connect my existing network to this new construction across the street. Well, you can do that. You can use fiber, integrate that media converter. You are now patching into your existing system that is all copper-based. Now, one of the places that we are seeing fiber getting deployed and used out of the gate, installed specifically for an application, is video distribution, okay? So most people know that today we are seeing video resolutions really start to expand and really start to expand quickly. Most people are installing 4K displays. 4K goes up to 18 gig. Bad news, 18 gig is bigger than a Cat 5, Cat 6, and even a Cat 7 cable's max capacity for bandwidth. They all max out at 10 gig. So when we talk about 4K, we talk about 444 color space and 60 frames per second and HDR. We're talking about 18 gig in bandwidth. If you want to send a native 4K signal, you have to incorporate fiber optic cabling. And certainly, if you want to future-proof your installation for 8K, which you can go out and get 8K displays and projectors now. There is 8K content. This is part of another course that we teach here at TechLogix and that we've taught for CEDIA now for quite some time. And now Bixie's, we're teaching Bixie integrators the same content. These bandwidths, they're getting pretty big, and you need an optical cable to move them around. Video extenders that are specifically designed and built for fiber optics allow you to send those signals, those big signals, allow you to send them natively, no compression needed, and also let you send them long distances. Now, another major advantage of fiber optic cabling, and this is very relevant to video distribution, is immunity. So fiber is completely immune to static, surges, electrical noise, lightning, RF interference. Fiber is a transport mechanism, a cabling infrastructure type that is incredibly reliable. And when we talk about sensitive video signals like HDMI, fiber is a very robust way to distribute those signals. So when we think about like digital signage in a factory or running that cable around a motor or some source of interference, or maybe we have lightning issues because we're in the Southeast, or static issues because we're in the Southwest, well, fiber solves those problems. Even in old buildings where we have different ground potentials, different ground planes, fiber is immune to those issues. So we see a lot more fiber optic extenders, video over fiber optic extenders being integrated for reliability, for distance, but also to handle the bandwidth of today's high definition signals. This same concept, the same video distribution concept, can also be applied to USB. So anybody who's worked with PCs, maybe you got a camera, a streaming camera, maybe you've got some peripherals like keyboards, mice, flash drives, whatever it may be. Well, USB is very limited in distance. USB is limited to 5 meters. That's the max spec length of a cable in the USB world. That's a problem in a lot of installations. 5 meters, 16.5 feet, doesn't go very far. Well, guess what? We can extend those distances using fiber optics, okay? Fiber cabling can drive these signals hundreds of feet with zero latency. Again, we're dealing with lasers. So as we think about how do I move my signals from point A to point B, yes, we can use an optical cable. That same cable that's used for networking, for video, for control, for audio, we also use for USB. Now, a couple of things that we want to mention here. One, all these electronics, hey, they need power. Fiber, again, it's immune to electrical issues because it doesn't transmit power. So you have to think about how do you power your devices at either end of the cable? Well, we can get power off the USB port. We can get power off the HDMI port. We can get power off of an AC port, as we plug the power supply into the wall. Different products call for different ways to get power into the system. Do a little bit of homework on your cable. Do a little homework on your electronics. It'll set you in the right direction. Just about all these have obviously tech specs that'll walk you through what we're looking for in an integration, or reach out to the factory. Folks are usually pretty willing to help. Final product we want to talk about today, we're coming up on our time limit. This tends to be a little bit specialized in terms of application, but converting one type of fiber to the other type of fiber, this does come up. And again, that media converter that we were talking about, that media converter that takes a twisted pair signal and converts it to an optical signal, well, the same philosophy, the same type of electronics can apply to fiber distribution. Now, inside different types of fiber optic cable, you get different core sizes. Different core sizes don't splice natively to each other. It doesn't work. So media converters, what they're going to do is they're going to bridge this gap, going from single mode to multi-mode and vice versa. This doesn't happen quite frequently. Usually folks will stick with one type of fiber throughout the entire installation, but from time to time, what we will see is somebody's got an existing infrastructure, short distance fiber runs. And when I say short distance, I mean less than 1,000 feet. But then they run into the need to extend one of those runs. Maybe it's across the street. Maybe it's to new construction. Maybe it's to a gate that's, a gate camera that's thousands of feet away. And now we have to change that fiber format. Well, media converters will splice these two different types of fiber optic cabling together. Now, we're getting ready to wrap up. I haven't seen any questions come in. That's usually a pretty good thing. If you do have questions, please type those into the GoToWebinar software. final thing that I want to mention today, other than I really appreciate everybody attending, is all of these applications that you've seen today, these are online. You can go on the TechLogix website. You can flip through these applications. You can browse the different products. You can look at the system diagrams. You can get more information, and you can also download PDFs that will walk through the pitfalls, things to look out for, things to optimize your installation, and they also include quick reference product guides. Really nice, handy little downloads on the TechLogix website, or certainly reach out to us, ask questions. We're here for you. We know fiber's new to most people, and we want to make this as easy as possible for folks to understand the technology, understand the application, learn how to terminate, really move forward with your project. I want to thank everybody for attending today. I want to encourage you to keep learning about this topic. Have a great rest of your day. Take care. Stay safe.